Welcome to the pitch. Forget the idea of a pristine green playing field. This surface is a chaotic, high-velocity battleground. Every sharp turn and explosive start kicks up plumes of fine dust, marking the intense physical struggle for territory. The friction of moving in this environment exacts a massive physical toll. An athlete here is constantly fighting dry, uneven ground, grinding against the cart-stock turf just to maintain traction and balance. In this environment, survival isn't just about technical skill. It's about maintaining momentum while a converging mass of opponents attempts to shut down every available path. That opposition operates as the defensive web. This is a coordinated unit of defenders moving in sync to suffocate open space. They work as a single unit, closing down lanes and herding the playmaker into increasingly confined areas where their options disappear. When multiple heavy defenders converge at high speed, they generate immense kinetic force. The surrounding space becomes a chaotic zone of flying particles and physical pressure. Curious, this creates a structural problem. How can a smaller, lighter athlete survive a collision with an incoming wall of heavy defenders moving at top speed? In a contest of raw mass and impact force, the smaller athlete faces a losing calculation. Since you cannot simply run through this much momentum, the solution has to be found in a different variable. To counter that overwhelming mass, the athlete relies on biokinetics, specifically the torque advantage. It starts with a micro-adjustment in posture. Throughout the sprint, the athlete maintains a constant 50 to 60-degree flexion in their knees, staying coiled rather than running upright. This diagram shows why that angle matters. The 50-degree bend keeps the center of gravity closer to the hip hinge, providing vital traction. While upright runners need time to build momentum, this coiled posture acts like an electric motor, delivering instantaneous power. The chasing defenders function more like heavy combustion engines. They require significant time and distance to alter their momentum once they've committed to a path. Due to this mismatch in power delivery, the Maestro can pivot a full 360 degrees while sprinting, leaving the heavier defenders unable to react. By prioritizing biokinetic efficiency over sheer size, the athlete effectively neutralizes the defender's advantage of mass. This physical advantage is only half of the escape. The movement must be guided by anticipatory logic, calculating the defender's momentum before they reach the target. This logic manifests as la pausa. At the height of a high-speed sprint, the athlete suddenly stops dead. This sudden stillness weaponizes the defender's own kinetic energy. Their own mass carries them right past the stationary athlete, forcing the defense out of position. Instead of using speed to outrun the trap, the athlete uses a sudden pause to induce panic, turning the defender's momentum against them. As the defenders slide out of position, the athlete immediately moves into the newly vacated space. This is spatial-temporal optimization. It is the calculation of exactly how much time is needed to cross a specific zone before the defense recovers. This top-down grid shows the geometry of the pitch. While the defense blocks standard vertical and horizontal lanes, the athlete uses diagonality, a single diagonal path that bypasses the defensive blocks entirely. Once the path is clear, the athlete strikes the ball, releasing the kinetic energy they've managed to preserve through these maneuvers. By calculating the geometry of the field, the Maestro dictates where the game goes, rather than reacting to the players around them. This mechanical persistence, the biological drive to maintain velocity against overwhelming external force, is what historians of the game call moral inertia. Dominance on the pitch comes from solving the unified field, viewing the entire game as a series of connected spatial problems, where a change in knee flexion leads to a tactical opening 30 yards away. Success here is found in the synthesis of biokinetics and spatial geometry. It is the ability to use the laws of physics to dismantle an opponent that is physically larger, but mechanically slower. To see more of the science behind the game, press the subscribe button on your screen.